Hey, welcome to today's webinar. It is my great pleasure to host Dr. Sheng-I Yang, who's assistant professor at the University of Tennessee, and Dr. Thomas Brandeis, who is a research forester with the Southern Research Station of the USDA Forest Service. They will talk about modeling allometric relationships for Caribbean trees, and they'll give a presentation that will be followed by a question-answer period. The plan is to wrap the official part up by 9 a.m. my time here in Vancouver, BC, and for past webinars, we've had the opportunity to stick around a little longer for more questions if there are more questions, and for just chatting some more. Before I hand this over to Tom and Sheng-I, I would first like to acknowledge that I'm hosting this webinar from my UBC office that is located on the traditional ancestral unceded territory of the Musqueam First Nation. The land UBC is situated on has always been a place of learning for the Musqueam, who for millennia have passed on their culture, history, traditions from one generation to the next in this site. Second, I would like to remind you that the webinar is being recorded and will be posted on the IUFRO webpage, and I'll send out that information to everybody who registered as soon as it's posted. Third, I would like to acknowledge that this webinar is part of the 2023 Forest Mensuration and Modelling Chats, which are organized by IUFRO Research Group 401, Forest Mensuration and Modeling. If you have speaker suggestions, please email them to me at bianca.eskelson@ubc.ca. As this is an IUFRO event, I would like to highlight IUFRO's mission to advance research excellence and knowledge sharing and to foster development of science-based solutions to forest-related challenges for the benefit of forest and people worldwide. The webinar series is being organized in the spirit of knowledge sharing and to allow for some interaction and networking across the globe. And now that I've covered the IUFRO requirements, please help me welcome Drs. Yang and Brandeis. And I'll quit sharing my screen. Yeah, that's perfect.
Great. Hello, everybody. I'm Sheng-I Yang, and
I'm Tom Brandeis.
So happy to share with you our work today, and Tom will go first.
All right, thank you.
Just click on this.
There we are. So to begin with, I'd like to give you all a broad overview of the Caribbean islands that were part of the study, with a brief mention of the forest and their general characteristics. And then also why there's a need for this type of growth and allometric modeling for these tree species. And then touch on the team that was assembled to work on this, to develop this modeling capability in the region, and explain to you the permanent plots from which the data were drawn and collected, and finally outline our plans for additional research using this really rich and interesting data set into the future. After that, I'll turn it over to Professor Yang, and he will go on with the modeling work itself. All right, so we worked on really four principal Caribbean island nations: Jamaica, Puerto Rico, and the U.S. Virgin Islands, and Trinidad and Tobago, as seen here on the map. And a little bit about Caribbean forests themselves. These islands are subtropical or tropical climates, depending on what classification system you use. They often have very steep topographical and environmental gradients, which result in very diverse forests over relatively short horizontal distances, ranging from very open canopy, dry subtropical forests to elfin cloud forests on the mountaintops. These forests are primarily dominated by broadleaf evergreen trees and, to a lesser extent, deciduous trees, or more deciduous trees in the lower elevations in the drier sites, with some palm component as well and tree ferns. While conifers are native to other islands in the Caribbean, they're not a major component in any of the forests in our study sites, although there are some non-native introductions and plantations on these islands. I'd also like to highlight the really high tree species diversity. These are islands with high numbers of endemic species due to that insularity. Plus, with the land use history, there's been a lot of introduction of tropical trees from other tropical areas of the world, and many have become naturalized. As an example of the diversity with the island-wide inventory of Puerto Rico that I work with, we regularly encounter over 300 tree species just in our inventory, and we can expect up to 700 different tree species. U.S. Virgin Islands, Jamaica will be very similar in diversity. U.S. Virgin Islands somewhat less because less topographic variation, less microclimates. Trinidad and Tobago possibly even higher due to their proximity to South America. And I mentioned land use and land use history and forest management. Each island has its own unique history and its relationship with its forest, but there are some commonalities. Really beginning with the history of deforestation for forest clearance, for the production of commodities for export in agriculture, which began at the time of European colonization for these islands. That went on for, in some cases, many decades, hundreds of years, until you arrived at a period, particularly around the beginning and the middle of the 19th century, 20th century, where we saw economic and social changes, which led largely to a lot of this agricultural land being abandoned and being followed by natural forest regeneration. Public reserve establishment that varies across the island, but demand for timber products mostly being met with imports. And on all the islands, these forests are really valued for their ecosystem services, for example, watershed protection and the importance of the production of fresh water on these islands. So why do we need these models? Primarily because accurate assessments of tree volume, biomass, carbon are needed for resource and land management decision-making, potential timber management on the islands. As you know, hurricanes are a common disturbance, and to assess hurricane damage and monitoring recovery, these models would be very useful. For international reporting to programs such as the FAO's Global Forest Resource Assessment, being able to model growth into the future is very useful. And sometimes with these models, we need to be able to estimate certain tree parameters. For example, reconstructing a broken top from a tree from its diameter to get at the tree height. And we know that tree height is also a very difficult variable to measure in the field. And we want to be able to project annual DBH increment into the future from these one-time measurements. There it is. So what's been done in the past in this field? Now, relationships and models of height to diameter and growth have been developed for many of the temperate and boreal forest species that we encounter, for example, in our FIA inventory, but much less so to the subtropical forests and tropical forests of the Caribbean. Now, there have been some Caribbean-specific models developed in the past, but usually based on very limited data sets. So we find now we have much more data available because of forest inventory efforts, particularly on the islands of Puerto Rico and the Virgin Islands, and on these permanent plots that are on Jamaica and Trinidad. And we're using that data to develop new, stronger models. So to help meet this need, Tamara Hartzell-Scaldi, she's with the U.S. Forest Service, International Institute of Tropical Forestry, brought together a team of scientists from Jamaica, Trinidad, the U.S. and Puerto Rico. This came from a Caribbean foresters meeting several years ago. This is our team here listed. So Randy Aird and O'Keefe Kerr work with us from the Jamaica Forestry Department. Mike Odom and Carlton Roberts from the University of West Indies in Trinidad and Tobago. You've met Sheng-I and myself, and then also from the U.S. Forest Service is from Fredo Marcano with the FIA program in Puerto Rico and Eileen Helmer with the IITF. And as a team, we assembled these data and the metadata from these permanent plots that I'm going to talk about next. So our study sites, starting off with Jamaica, the data came from rectangular vegetative assessment permanent sampling plots that were established to monitor forest ecosystems. The set we're using were located in the Cockpit Country, karst area, which stretches across the parishes of Trelawney, St. Elizabeth, and St. James. These plots were first measured in 2007 and also in 2008. These assessments, or rather the measurements, the assessments were repeated in 2014, so we have 2 points in time. Diameters were measured on all trees on these plots down to 2 centimeters, but tree heights weren't measured, unfortunately. So for this first phase of the work, we won't be using the Jamaica data. The next study sites I'd like to talk about are in Puerto Rico and the U.S. Virgin Islands. So these plots are part of the island-wide systematic sampling of permanent forest inventory and analysis plots that are part of our national forest inventory. In the case of Puerto Rico, we have 4 full remeasurements of those plots across the islands, starting in 2004 and ending in the most recent 2019. And we have 3 remeasurements of the plots in the U.S. Virgin Islands, so 2004, but stopping in 2014. 2019 data collection was halted. We were a little bit late with starting, and then COVID-19 hit, and we had to skip this entire cycle, unfortunately. And if you're familiar with FIA at all, I'll just say that we did standard plot layout and data collection protocols, which means we measured all trees down to 12.7 centimeters on a subplot, then down to 2.5 centimeters on microplots. We also noted tree damage and whether plots were damaged by hurricanes and flagged all the plots with that information. Final set of study sites come from Trinidad. These were permanent plots established by the Forest Resource Inventory and Management section of the Forestry Division of the Republic, Trinidad and Tobago. And these are larger 1 hectare plots, 144, that were over the island of Trinidad that were used for monitoring forest timber resource turnover and growth. Most of these in the southeast of the country were established in 1983 to 1984, with some though as late as 1998. And some of these plots have been measured up to 9 times at 3-year intervals. So a lot of remeasurement data there. They measured trees down to 10 centimeters for non-commercial species. 10 centimeters for all species except non-commercial ones, which were measured down to 20 centimeters. So with all this data and so many questions we could be asking, we're going to work through it in phases. And what we're talking about today is the first phase. We're looking to develop models that predict total tree height. The next phase after this work, we'll begin to work with individual tree growth rate models. So right now we're working with 2 data sets. The one that has DBH measured at least once and total height at least once. And that's the trees from Puerto Rico, U.S. Virgin Islands, and Trinidad. And we're flagging whether or not these trees were damaged by hurricanes, excluding them in initial work, but considering how to include them in the future. And then for growth modeling, we're going to use all trees that had multiple DBH measurements taken over the periods, in some cases for over a 20-year period, which is really great. And that will be from all 4 of our island groups. So we're going to start today, as I mentioned, by focusing on the height to diameter relationships. And I'll give a little bit on the summary statistics. So these are the numbers of plots, numbers of observations, and number of species observed on these plots, range of diameters, and total heights. So what I really like to highlight here We're dealing with data from over 645 plots, keeping in mind that the Puerto Rico Virgin Island plots are much smaller than the Trinidad and Tobago ones. The number of observations, so this isn't individual trees, but many of these trees have been measured multiple times, but it's still over 37,000 observations. And although there is some species overlap between the islands being shared, so give you an idea that there's over 464 different species records. And here you can see the range of diameters we're looking at, from a low of the minimums of 1 inch, 2.5 centimeters, up to over a meter, almost 1.5 meters in some examples. And then also with the heights, so maximum heights up to 35 to 50 meters of height on these trees. So this is the range we can build these models for. We also are doing some modeling with some ancillary data and calculating stand characteristics to include in these models. So, and this includes quadratic mean diameter, number of trees per hectare, basal area per hectare. This is all computed for the plots and appended to the tree records we use for the modeling. A little note that yes, it is condition class if you're familiar with FI data. We also calculated a competition index, which is the ratio of that subject tree's diameter to the sample unit level quadratic mean diameter. And then in addition to this, we have 23 different climate, topography, and geology potential covariates. So ancillary data we brought in from different data sources, such as World Climate Model, Shuttle DEM, and the geology map for the Caribbean. And with that, I think it is time for me to turn over to Sheng-I. Please go ahead.
Thanks, Dr. Brandeis. So I'm going to continue talk about this project and especially focus on the modeling part. So what Tom just mentioned, we would like to build the species-specific prediction for different type of species in the islands. And I believe some of you have been working on the diverse species, multi-species stands in the past. The one main challenge to deal with this kind of data set is the small sample size for uncommon species. Some species rare and it's hard to find multiple individuals in the population. So how can we incorporate those diverse species in the models? And by reviewing the literature, there are two different approaches commonly used. The approach one is to group the data, so can be based on the tree characteristics or functional or ecological traits, which has been commonly done in the literature. And in the recent decades, another approach commonly used is use the mixed effect models and use species or genus as a random effect, so that we don't need to handle the grouping issues. So based on these, we choose the second option and then use the mixed effect models to test if we can build a high diameter relationship model for these data sets. Then, but I believe some of you already have some experience building mixed effects models. The one main challenge that I found is for the parametric method, it's hard to find a relationship among variables, especially we have 20-ish variables in our models. It's hard to know, to figure out what is the best relationship among them and to determine the initial values in the model fitting. So to handle these challenges, a possible solution used in variable selection is rely on the kind of machine learning techniques and random forest algorithm, so that we don't need to specifically identify the relationship among different variables in equations. We just run random forest algorithm can be used to handle these variables and also to select the important variables. But the random forest algorithm also have some limitations, especially for a diverse species. If you want to include the species in the model, it will include the high cardinality of the model, which can be potentially overfitting the random forest algorithm and also increase the computation time. So even we choose the random forest algorithm, there are still have some difficulty with these diverse species data. So we are trying to find what will be a better solution for this one, and then we found the mixed effect random forest algorithm, which include the random forest algorithm in the mixed effect model framework. So basically, it replaced that parametric part with the random forest algorithm so that we don't need to really have a specific equation form to estimate those mixed effects. We just put the variables into the random forest algorithm, then the model can give us the results. But we still retain that random effect in the mixed model so that we can predict each species-specific prediction. So here is the equation form for the mixed effect random forest algorithms. And let me provide you a more specific how mixed effect random forest algorithm works in feeding. So first of all, we build a random forest with the transform response. And so the idea is we subtract that random effect from the response variable. So we remove the effect of random effects, and then we use the fixed effect portion to fit the model with random forest. And then we use the residual calculate from the fitted and observed response to estimate the random effects. Then we use that estimate to build a new transform response in step 1 and then fit the model repeatedly until the parameters converge. That's the basic procedure of fitting the mixed effect random forest algorithm. So in addition to use the mixed effect random forest algorithm, we think it's better to also include random forest algorithm without species include and see what serve as a baseline comparison. And then since parametric mixed model is still pretty commonly used in practice, so we think it's good to still include a parametric mixed model with and without environmental variables include there and see which model perform better. And specifically, we include the tree data and auxiliary variables, as Tom mentioned, in building the full model for random forest and mixed effect random forest models. And then we rank the variables by importance score. And once we have that list of variables ranked by the importance score, we fit the submodels sequentially. So each time we put into a new variable, a variable based on the importance, and then to determine what is the best model for our final model for random forest and mixed effect random forest models. And we used that subset of variables we select to build a parametric mixed model with and without environmental variables. So we found in Puerto Rico and US Virgin Island, these parametric model perform better, and for the other island, the other model perform better. So we are going to just use these two to build the parametric mixed models. And let's see some results. First of all, the variable selection. There are several variables for selecting the final model, and here's the table. And let's take a look at here. The DPH, of course, we want to build a high diameter relationship model, so DPH is the key variable. But in addition to DPH, we found the competition index is also important in the model. So for all the combinations and all islands. And then in addition to those three variables, we found the precipitation also important in prediction. Several combinations show the precipitations in the model have a contribution to the prediction. And let's take a look at the model performance here. The mean bias and RMSE we calculate for 4 different models and among 3 different islands. First of all, we can see here in general, all the models show unbiased prediction in general across 3 islands, and no matter the parametric model or non-parametric models. But here we see higher RMS in Trinidad compared to other 2 islands. We found the mixed effect random forest model produce slightly higher precision level compared to other candidates. And let's take a closer look at the model performance by tree size. We divide the entire data set by islands into 3 different tree size, small, medium, large. As we can see here, the parametric model with and without environmental variable include have slightly biased prediction across different tree size. And also we found the US Virgin Island generally has a lower RMSE compared to other islands. And let's look at the graph, the predicted value versus the observed value across different islands and different models. Let's look at Puerto Rico first. So we can see the general patterns and follow the diagonal line, but if we can see here for a large, very large tree or very small tree, we see some bias prediction over there. And we are thinking about it's probably because there's a lot of large variation in the tree, especially we don't have many data points of those really large tree there. So it's possible to see these bias prediction. And let's move to the Virgin Island. Generally, the Virgin Island, as I mentioned before, the Virgin Island prediction is better than other 2 islands. And we can see, yeah, the dots are really pretty close to the diagonal line here. But when we look at the Trinidad data, we can see the parametric model did not do really well compared to the random forest or mixed effect random forest models. And also we can see a lot of variation in the data set. One possible explanation of this is because, as Tom just mentioned, the Trinidad, in the data, we didn't record the hurricane or other damage on the trees. And we have a relatively small sample size in the island. So it's possible why we can see this variation in Trinidad. So just a quick summary about what we found here. The first one, the total tree height can be predicted without bias by these models we select, but we found the mixed effect random forest model improved the prediction precision compared to other models. And also we found the deviation competition index are key variables in predicting tree height if we don't have the other environmental variables include. And as I point out in the table, the precipitation variables show important in prediction total tree height for these subtropical forests. So as Tom just mentioned why we need these models, one possible application of the models in Caribbean seas, we can use that to estimate the unbroken tree height, the original tree height of those top broken trees, and then to use that to predict the volume or to assess the damage of hurricanes or the tree health. And before we go into the last few slides, I would like to give some reminders about what we found here and what's the best way to take away the results. We found the MERV model can be used to predict the height for these data sets, but as I mentioned, mixed effect random forest model is just one of the many solutions for modeling height and diameter relationships. It doesn't mean the MERV model is the best one to go with for other data sets or for all the species, but it is a workable solution. And the models here, we are not proposing an optimal model for all the species. We just want to look at what are the alternative modeling approach we can use. So there are several work or study can be done based on what we found here, such as to investigating different model sensitivity on the different scenarios, different forest types or different species sample size, and also compare the model performance among different species as well. And also it's possible to include other variables in model building, which may improve the model prediction accuracy. And also we have published this work in forest ecology and management in last year. So if you want to know more details about what we have done and some background information, some more details, please feel free to check out our paper here. And then as Tom just mentioned, we just finished the first phase, part of the first phase of these projects. And so the next step, we want to look at more models and see if we can replace the current model settings in the US Forest Service current prediction system for Caribbean trees. And then we will start working on the growth model for those trees. With that, with the final slides, and thank you for your listening.
Yeah, thank you both to both of you for the great presentation. It's really nice to see the FIA data being used and to get some ideas on how to deal with variable selection, especially with lots of climate variables. I will quickly share my screen because let's do this working. I would like to draw your attention to an upcoming webinar on probably March 28th. Oh, and I put the date wrong. This should be 2023. I messed that up. Dr. Sonja Vospernik, and I probably pronounced the last name wrong, from Boca University will talk about talk about tree species growth response to climate and oak pine mixtures across Europe. And you can get details about upcoming webinars in the webinar series by subscribing to the Division 4 mailing list and also checking out the IUFRO calendar. And if you have speaker suggestions, please email me. And thank you for your attention, and please help me in thanking Sheng-I and Tom, and I will turn off the recording now and open up the floor to questions.